Relating to also answering question number 3, being given a system A, B and B, C, the lever, and question asking what is the distance D, which is indicate from B to C point, and this problem only a singular force, which is force F 200 Newton, being given moment A 120 Newton meter in clockwise direction. So ahead to the problem solving, I'm using a moment analysis, and in that we need to include all the moment in the system. So this is the free body diagram. As you can see, the member A, point B and C, a singular force. So this is all pretty much it for FBD. And for the moment equation, we have negative 2120 kilonewton millimeter. I get it from convert 120 Newton meter into Newton millimeter. So there is the equation. There is not solution. Is a solution for unit conversion. So we'll get 120 kilonewton millimeter. We need to make sure that the distance were in the same unit. Otherwise, we get the wrong analysis. So since that the unit that we are dealing with millimeter, so that's why I need to convert into millimeter. Or you can change millimeter into meter, it's up to you. But in this case, I'm dealing with a distance millimeter, so I need to convert Newton meter into Newton millimeter. So we'll get 120 kilo Newton millimeter. Negative right here indicate that this moment A were exerted clockwise direction. So we'll have a moment be given from the force in X and Y direction. So I make another free body diagram in AutoCAD so you can understand more better. First, we need to classify what is the axis for the system. So as you can see, there is a green line right here indicate that this is my Y and this is my X axis. Of course, you can classify by your own self which line that you want to make it as your own axis, so that the computation of your force need to respect onto this axis. So this is my axis, Y and X axis. So the red line right here indicate that this is the force is at 15 degree. We have another angle being given in the equation, 13 degree. So we need first to compute this force into Y and X axis. So I make the movement of X line onto the force. So we will get like this. So this three line is the three rectangular force for this 200 Newton. So we'll get like this. The angle will be 45 degree. So this will be the the Y axis, and this will be the X axis. So the blue line indicate that this is the resultant force, which is 200 Newton meter. So you need to convert this 200 Newton meter into X and Y components, since that our axis will be in this condition. So that's why if we are using a three-go rule, so if you want to find out what is the force in Y direction, you need to use a sine, and X direction you need to use a cos. So that's why in this problem solving, sine 45 degree, it is for summation of force, is not summation but the force in Y direction. Meanwhile, for the Y component, it will be 200 cos 45 degree. So as we are dealing with a moment, you need to know what is the perpendicular distance. We know that the Y and X component of force, so we need to classify what is the perpendicular distance for both of these force. Going back to the AutoCAD, the direction of the vertical force or y component force will be in this direction. So perpendicular distance is from point this onto this one. So from point A to point B, there will be 300 millimeter. From this point onto this point, we need to do a trigonometry cos 13 degree. 13 degree. The distance between this onto this will be D. So we will get this distance from this point onto this point by D cos 13 degree. So we can summarize that the perpendicular distance for y component, that will be 300 plus by D cos 13 degree. Meanwhile, for the perpendicular distance, x component of force, the direction of the force will be in this direction. So the perpendicular distance will be 19 degree. The distance which is 19 degree upon the surface, upon the direction of force will be from this point onto this point. So you can get it from trigonometry sine. So that's why we'll get the perpendicular distance for the x component of force will be equal to d sine 13 degree. So this equation you need to include onto the first equation. So you do a math because there is only a singular unknown, so you can solve for D, which is 4.04 millimeter. It is because we already changed the unit onto millimeter since the beginning, so that's why we'll get millimeter right here. So I hope it's clear. It is hard to explain because it is a little bit tricky to compute force. You need to classify the right axis. It depends on you. But for me, there is more logic and easier to analyze. You need to classify your own axis and compute the force respect onto the axis and to find out what is the perpendicular distance. So with that being said, I think that's all. Thank you.